Hi everyone, thank you for coming. We'll continue today in Python. So today we're going to cover object-oriented programming in Python. Alright, so object-oriented programming is a common topic that you'll see in many programming languages. I'm sure you have done it in one of the courses you took in your majors, computer science or computer engineering. So it's the same concept, the same principle. Just focus on the slide, not on me. Just today we'll tell you how to use it in Python. We are not here to explain object-oriented programming for you. You should know it before you come to this class. This is a graduate level course that you should know object-oriented programming. Anyways, so when we talk about object-oriented programming, we talk about classes, right? Creating a class, all right? As you know, for example, we could, for example, have x equals y. Or not y, let's say x equals, for example, 10. Okay, what is x?
Okay.
It's an object. Okay, it's an object of a class. We said everything in Python is an object of a class. So what is this object? Is of a class integer. Of a class integer. So it's a built-in class that we don't have to write. When you say, for example, y equals, for example, hello, okay, this is an object from a string, a class, which is written for you, right? And each class was built from has attributes and methods. Attributes and methods. Okay. So and today we'll learn how to write ourselves, how to write the classes. So for example, to start a class, you could say with the word class, for example, class, okay? You give it a name, okay? A, for example, okay, call. All right. Each class is inherited from major class in Python, which is objects. Okay, objects. I could put in here objects like this. I could like this objects. Or I could not. I mean, I should, like this. It's like understood. If I don't put it, it's coming from the objects. Okay, and this is inheritance. When you talk about object-oriented programming, classes are inheriting classes, right? So we'll talk about inheritance. But anyways, so inside here, for example, what you're gonna have attributes. You'll have attributes. All right. So you have the constructor, let's say, which is underscore init. Okay. Okay. Let's say, for example, we have self. Okay. Self, and always we have to pass self. We have to pass, the object. The first thing in the function, we have to pass the object itself. We use the word self. So self, for example, first name, okay, and self, last name, let's say, name, okay, equals, right? So in here, let's say that we have two attributes, so we're gonna pass the object, and then after that, the first name, and then after that, the last name, okay, and any function we define has to have two columns here. So self first name equals first name. Last name equals last name, for example. All right. All right. So in here, this is a class. What's the name of the class? Is A. How many attributes it has? Two attributes, first name and the last name. Then after that, we could have as many methods we want. For example, def. Okay, this is create, a function called full name. Full name. And in the full name, what we do, okay, we create, for example, the full name. Okay, full name variable, full name is called fn for short. Fn equals what? Equals self dot first name, let's say first name, plus self dot last name, return full name. So this is a very simple class. The name of the class is A. It is inherited from objects, all right? And it has two attributes. What is the first attribute? Is the first name, and the second attribute is the last name, all right? All right. For the init, this init is a constructor. That's how constructor construct the function. All right. So the first name will pass to the first name. The last name will pass the last name. And always in Python, we have to pass the object itself to the function. Okay, to the function. So here also self. Okay. Then we have one method which returns the full name, which returns the full name. Class. One class, yes.
Always the constructor has the name in it?
Yes. The constructor always underscore init. All right? Do you have to have it? You don't. Because if you don't have it, it will be inherited from the object's class. Okay? If you had it, then you're overriding the original. Okay. Now, inside the program, if I need to create a class A, how can I create it? So, for example, I could, for example, have, okay, in here, for example, Joe equals A, all right? And I have to pass the name, for example, which is Joe, last name, Chris. So now I created an object. Okay? So I pass the first name and the last name. If I need to print the full name, how can I print the full name? Joe dot full name and to print the full name. I'm calling the function I'm creating, right? All right. I could also, create another class. Let's go here. So I could have another class called the class B, inherited from A column. All right, and I could create like the init constructor def init. Okay. Self, always I have to pass self. Okay, and age, for example. Column. So I have self dot age equals age. Right? Age equals age. All right. So now, if I create, for example, Shakur, for example, Shakur. Okay. And it's from a class B, so Shakur, okay, it's from, so B, it will be Shakur, okay, Abuznaid, 29. Will it work? Will it work?
No.
Why?
Because the constructor only takes
Constructor only take
once.
age, right? But what if I call super in here, super, okay, super, which is, it will be the A, okay, super, okay, an A, and I call init. Will it work? It will occur. Where? Yes. So here we. So now, okay. So let me remove this to initialize. Okay, and let me remove this in here. So I'm gonna also this. So I'm gonna go first name. Okay, last name. And age, right? So to initialize the first and last name, what I will do, I will call a dot init this will initialize what? I'm gonna go in here and we'll call this, will initialize the first name and the last name, okay? And for age, I could say self dot age equals age. Right? So this class B is inherited from A. What does it mean inherited from A? That means it will have all the attributes and methods of A. It will have all the attributes and methods of A. In addition to some other attributes I add in here and methods I add in here. So if there is a new method I add to B, I cannot use in A. But any method in A I could use in B. I can use in B. Clear? Alright? So in here I created a constructor. I created here B. So if for example now, if I say Shakur dot full name, okay, or print, what it will give me? Shakur Abu's name. Do I have a full name method in here?
No.
I don't. Where is it coming from? From there. Alright? So that's what we do. That's what we do. We create like classes, multiple classes. That's how it's object-oriented programming. So for each class, the healthy way for creating, you create one file, okay, and you create the classes. Okay, the classes will have two components. What are the two components? Attributes and methods. All right, and so if you have, in our example, you're gonna create this. For example, you could call this, for example, a dot what? by, and this you call it b dot py for Python, right? And then you create a third file. Let's call this, the third file is, let's say, we call it, for example, third file, we call it, one program, right? We call it whatever. I call it, okay, student, whatever. So student .py. So what is the first thing that you need to have in this file? Import A, import B, and then all the calls from here. All the calls from here. If, for example, I need to create an object, Shakur, for example. Very simple. Shakur equals to what? B, Shakur, Abu's name, 29. I'm lying, that's not my age. Okay, so 29, right? So now I have created an object from a third file. Okay, is there a mistake in here? Is there a mistake? Yeah, there is a mistake, a small mistake, because this will not know. So we have to say we are importing from a file called B, class B. Okay. All right. If I don't want to do that, very simple. I could change this, and I could write from objects import what? B. Then I don't have to do this. We have learned that before, right? Right? Yes.
In the constructor from class A over there, we don't need to give in first name and last name.
Here?
Yes, second
Here?
constructor.
You mean here?
Yeah.
Yes, you need. So in here, for example, you can say first name, last name. You need. Okay. All right. All right. So that's basically it. So you know how to create it in a very simple. Let's take a look in the PowerPoint what we have. All right. Quickly, we'll go over that. All right. Any questions so far? I think it's something that you should know by now. Okay. Oops. All right. So how to? Okay. All right. So this is a little bit overview about object-oriented programming terminology, like a class variable, data member, function, instance variable, inheritance, instance, method, object. I mean, I'm sure you are familiar with that. If not, it's your responsibility to get familiar. Okay. We already covered that. So basically, in here, what we have, we create an object. Object which will have like attributes and methods. So as an example, product one is an object of a class product. Okay, it has the name, the price, and the discount. This is another also attribute. So 3 attributes, right? So if I need to create a product's I mean, actually, we could, what I could do, go in here, and go in here, for example, product viewer. So as you see in here, there is 2 files. The first one is the object. So let's try to open it in here. Yeah. Charm then. So let's say file. I'm trying to get the file from my Google Drive, but it's not linking to my Google Drive. That's really weird. Let's just try to do one thing in here. Let's try to. Okay. To connect again. So file, open. It's not connected to my Google file. Why? It's really weird. Cancel this. Now we can see it. That's interesting. Okay. So let's open it file. Open. No. Why? Something is not linking my Google. I'm running everything from my old Google Drive, just not linking to it. Anyways, so let's see what will happen. It's there. I'm becoming stubborn. I need it to run. So I'm not sure what's going on. Why is it? Maybe I have to restart the machine. I have no idea. Anyways, so anyways, I wanted to run the program for you. Anyways, I'm not sure if you can see. So anyways, if you look in here, I'm trying to create a class product. Okay. So we start with the constructor. Can you see in the back there? Can you see? Huh? You have it in there? In that computer? Okay. So I could do like that. I wanted to run it, but that's fine. Come on. Yes. In here. So that's a product, right? So we start always with a constructor. So we have always, we start with any method inside the class, we pass the object. So we use the self. We have the first attribute is name, price, discount, We did this program before. So how many attributes in this class? 3 attributes. And the fourth we passed is the object. Always you have to start with the self, right? So self.name equals name. Self.price, price. Self.discount is a discount. So what is this in here? The constructor. Now I could have many methods as I want. So the first method I have in here, which is the method that uses 2 attributes only. What I do, get discount amount. How can I get the discount amount? I have the discount percentage and I have the price, right? So very simple. Return self price multiplied by self discount percent over 100. So that I will know how much is the discount amount. In here, I will calculate a method that calls another method. So in here, get discount price. Discount price. So what is the discount price? Is the price minus the discount amount will give me the discounted price. The discounted price, right? So very simple. Return self price. What is the price in here? Is the attribute minus what I'm doing in here. I'm calling a method. Where is the method? It's in the class. What does this method do? Calculate the discount. Price minus the discount will give me what? The discount price, the final price. All right? So that's a class. If I put it in one file, I call it objects. All right? I don't do any work. That's the healthy way of doing it. So you create a file for the class, okay? And then you create another file, for example, called product viewer. That's where your messy work. Okay? So what I do the first thing, I could say import. I could say import product. If I say only import product, I have to use the file name in every call for anything from that product. So from objects, because product is always inherited from objects. All right. So create 2 products. Product 1, product 2. Product. Okay. The product name, the price, the discount percentage. Second product. Price name, discount amount, and the discount percentage, which is 0. There is no discount. All right. Then this is my main page. So print product data. That's what product data. Print name, product name. It will give you the product name. Price, give you the price. Print discount percentage. This is discount percentage. Discount price. This is discount price. Right. Simple, very simple example. We're gonna have a class of products. Keep it in one file, and then your dirty work is not a dirty, but the work that you need to do, you call it from here. You have a project that needs like 5, 6, 7 classes. If I were you, either I create one file for the classes, put them together. That's one way. Or if the classes are huge, massive work, keep each class in one file. So you create one class in one file, you do all the tests. You test their methods you have written, they are working fine. You do stress test with different inputs and all of that. So it's all ready. So you keep the class by itself. All right? So class 2, the same thing. Then you have all your main program from a different file. Okay? So that's the nice thing about object-oriented programming. You could divide your work into modules. So I already explained that. All right? This is how we created the product. All right? Okay. Now, if I need to assign a value, so product 1, discount percent equals 40%. So what I'm doing in here, I'm assigning a value to the attribute of what? Of an object. What's the name of the object? Product 1, which is instantiated from a class. What's the name of the class? Product. Okay? In here, what I'm doing in here, percent, product 1, discount percent. What I'm doing in here, I'm reading the value and saving in the variable. All right? So you could call method, you could change the attributes, you could read the attributes, you could do whatever you do. So it's exactly like you're putting all the attributes in one object. All right, let's talk. We already spoke about the constructor. So the constructor always has to start with the self and the other parameters. Do I have to include all the parameters? I don't. Okay, I don't. Okay, so in here, for example, in itself, did I include the parameters? I did not. So in here, by default, it will set name to where? To what? Empty string. Price to 0. Discount percent to 0. Alright? So for this one, if I need to create an object with this constructor, all I have to say product equals product with capital P. I don't pass any parameters. Why I don't pass any parameters? Because when I define the init, I did not have any parameters passed. Clear? All right. So in here, for example, okay. Now, what's the problem with this way? When I create an object, I have to go individually for each attribute and assign a value. So in here, I created an object which is called a product. All right. Then I said product.name, I assign the value. Product.price, I assign the value. Product.discount, I assign another value. All right. You could do that, but maybe it's not the most healthy way. Look in here. In here, I passed the parameters. So in it, I have the name, the price, the discount, percent. Name, price, discount, percent. So this class has 3 parameters. In the constructor, I pass the 3 parameters. So when I create the object, very simple, product, I put parentheses and I pass the 3 attributes. That's one way of doing it. Do I have, like the previous one, to go and do the assignment? I don't, unless I want to change the values. Unless I want to change the values. In here, what I'm adding in here, I'm adding all the parameters, but with the default values. There's a default values. So if I don't pass the parameter when I'm calling the object, when I'm initiating the object, it will assign it what? The default value. So what is the default value for name? Null. Price, 0.0. For discount percentage, 0%. Okay? So that's a constructor. So I could call it this way, where I pass the 3 values. Is there a problem? No problem. In here, okay, what I did, okay, in here, I said name, okay. I have also, I forgot to mention that when I pass the parameters, they have to be in order. They have to be in order. If I don't want them in order, I have to say, so what I say, name equals this. Price equals this. Where's the third one? It will pick the default value. It will pick the default value. Depends on your program, okay? For me, I think, try to have a default values when you have, okay? It will make it less problems, okay? And when you pass it, okay, you know, if you decide to pass all the arguments, that's fine, you don't have. But if you're gonna pass 2 out of 3 or 2 out of 5, always include the name of the attribute. All right. Always try to write the code to make it as less as possible confusing, as less as possible confusing. So myself also, when I program, usually even if I'm passing the 3 parameters, I feel comfortable to add the attribute name, but you don't have to. Okay? So you could do whatever you like. So this is okay. Now the methods inside the class. You could write the methods in a different way. So for example, here, what is this method? Get discount amount. Always for any method inside the class, the first parameter you pass to it is self. Never forget self. Okay? Okay, so discount amount self, which is price dot self discount, whatever, is a mathematical operation. And you return a value. So usually for any method, it has an input. Where does the input go? Between these two here. And it has an output. What is the output? The return value. The return value. Remember that in Python, the input could be multiple values and the output could be also multiple values. Multiple values. Okay? So this is a method. Okay? To call this method is a very simple. You have to proceed it with what? With the object name. With the object name. So we're saying, let's go to object product. Okay. Myself, by the way, I don't like the convention in this book that they call the class with a product with capital P and the object's product with a small p confusing, right? If I'm writing the book, I'll use P1, for example, or something just to make it different. But you understand like this, right? So here I'm calling the method. I'm calling the method. A more concise way to code this method is like this. Okay? Right away return. After the return, you write the equation. And here we have created the equation. Then we pass the variable. We created an extra variable. All right? Now, which one is better? This or this? This or this? Myself, I like to return a simple value. So I like to put like details in here. I don't like to return a whole sentence. Okay? If you are expert programmer, you might, that's what you do. Okay? But myself, I like the code to be more clear. Okay? Add one more variable, save the data inside it, and then return that value. Okay? Code that calls this method is the same thing. The same thing. So I think there is nothing new so far. Okay? This is another method. Okay? Where I have a process. Where I have a process. Okay? And that's how I call the method. Okay. So this is now a method. The method before in here did not accept parameters, right? Can you accept parameters in the method? As much as you want. As much as you want. So in here, so get the price string, and you're gonna pass a country. What is a country in here? Import. Is it an attribute? Is it an attribute? No. It's not an attribute. It's a variable. Okay? All right? Could it be an attribute? Yes, it could. It could be an attribute. It could be a different variable that you could pass. So, okay, price string. Okay, so I'm trying to format the price from float to where? To what? To a string. So I'm saving it to the price string. If the country is US, then the price string, you're going to add to it what? The US dollar. Else if country DE, what's DE, then price string plus euro for the euro, right? And the return price string. So when you call this print price and product, get the price string US. What is the US in here? The parameter that we passed. The parameter you passed, which is the country. All right? So you could have the method pass parameters to it. If you forget to pass the parameter, so in here what you are saying, that this function has to have a parameter. If you don't pass the parameter like what you did in here, what will give you? Give you an error. How we can solve this problem? Give a default value. If you give a default value, you don't pass it, then we'll take the default value. If you don't put a default value, always you have to include this parameter. So you could run this program. I mean, there's a lot of programs in the PowerPoint, you could run it. So this is the program that's in here. Now, there is another program in here that, you know, you could create object of the objects. So for example, die, you know what's die? You know, die it has 6 faces, right? So if I have a die, I'm creating an object called a die or a class called a die, a class, call it a die class, call it a die. Okay. So what attributes I could have for a die? Value, right? So I could say self, for example, whatever. You know, def. Okay. The value, right? Self, that value, right? Equals, for example, value, right? Okay. Any other attributes for any die?
No.
No. Okay. Any die, when you hold a die, when you look at it, what is the most important attribute? The number. When you flip it, okay, what's the value, right? Right? Size is not an attribute. Is it an attribute? All dies have set size, right? Color, is it an attribute? It's not important. Die. I mean, we'll talk about the die from functionality point of view, right? Okay, so this is the one attribute, okay? What methods we need for a die? What do you do with a die? You eat it? Roll it. Any other function? So for a die class, I need one method, which is roll, and one attribute, which is the value. Do I need anything else? That's what you'll do when you're trying to create your classes for your projects. Okay? What is the first thing you're going to think about? What attributes I need, right? And what methods I need to write. Do I need anything? So all of that. So this is die, right? Okay. So the die. So die, it has a value and one function or one method, which is roll. There is a dice. What is a dice? Is a list. Dice is a list of multiple die. So it's not one. Now I have 3, for example, list. So I have a list, for example, die 0, okay, and die 1, and die 2, for example. So I have a list of what? Dice. So now I'm not rolling 1, I'm rolling how many? 3, right? So now I have another class which is dice. It has attribute which is a list of dice, and what now for this game, what kind of methods are gonna need? So each dice could have one or more die, right? So I should have a method to add a die to the list. As an example, in here, how many dice I have in this dice? 3. If I want to make them 4, what should I run? Add a die. Okay. What other method? Run them all. Okay. For this application, do I need anything else?
No.
No. Okay, I have a die. All right. It has one function, one method, which is roll, and has one value. I created another class which could have one or more, as much as you want, die. All right. I could add a die. I could add a function in here, by the way, remove a die, right? If I need to, right? And then roll them all. I could add a function, add them up. After I roll the values, add them up. That means what I want to do. Okay. So what's this example? What we try to tell you? That you could have a class, okay, a class which is built of other classes. Do we need to go that far? We don't. What if I don't have a die? I have integer in here. What is integer by itself? A class. So this class has an object of integers. Clear? All right, so let's take a look at this program quickly. It's your responsibility to run them. You have the problems in here, you understand them. I mean, did you have problems the last weeks in the examples? Running them? No? Everything is good? Okay. So import random. So there is a module random because we're going to work with random. Class die. So I initialize it to the value, and I have one method which is roll. Done. This is one class. Another class which I have in here, dice. It's built of what? A list. A list. Okay, a list, right? A list. List of what? Of multiple die in here. So I have a function add a die. So when I have the list append, okay, and when I have when I need to roll, I have to for die in self list, and then I call the roll to roll it. Okay. Okay. So class and the class. Okay. How I initialize the value? Very simple. Okay. Random range from 1 to 7. Why from 1 to 7? Because in random it runs from 1 to the last minus 1 to the 6, right? We know what's the range, right? So I want to run it, but I have no idea why. It's not connecting with my C drive, so I have no idea why. Check it out. Thank you for being patient. I don't think you have any other option anyways. Alright, which one? Let's try this. Okay, so this is the class, the classes we okay, so this is the class for die and the class for die. If I need to run it, okay, so enter the number of dice to roll, let's say 3. It run them and gave you 1. The first one gave you 1. The second one gave you 5. The third one, if you need to roll again, let's say again a yes. Okay, I'm gonna roll a 21. 20 dice. Oh, not sure what I did. Okay, let's say 20. Okay, so it's run like 20 dice. So the dice has how many die? 20, and run all of them. Okay, you understand what's okay? All right. So the idea in here, they use this for another program, which is like okay. So there is a game. Let's play the game for a second before we break. Okay. Okay. So with the dice, you take a look at the program. Just like myself, I'm gonna play it with you. Okay. I need to play it 3 times. Okay, who are volunteers to play the game? 1, 2nd, 3rd, 2 only. All right, 2. I forgot to mention that the winner gonna get $5. Yeah, okay, so 2 is enough. Okay, so who wanna start? Here. So the game in here is you're gonna roll, right? You could roll and hold. So you could roll as much as you want. So you could roll, okay? And they're gonna add up. When you get to the 20, you are the winner. All right? You could roll if you get 6 in the counter. You get 3, 9 in the counter. You get 1, 0. So if you get 1, it goes 0, right? All right. But if you hold, then you go to the next level, okay, and you'll maintain the amount. So let's say, for example, okay, let's example that you run first time. You say run, 6. How much is the counter? 6. Run. Okay, you got 3. How much is the counter? 9. You say run. You get 1. How much is the counter? 0. Okay, 0. All right. If you say hold, if you say before you come in here, still it's 9. Okay. Okay. You say hold. The 9 will be hold. It will not go to 0. But the problem now, you finished 1 level. 1 level. Now you're gonna go to the 2nd level. So if you say run 2, how much it will be? 11. All right. Let's say you run, you get 1. How much it will be?
0.
9. Because from the first level you hold until 9, right? Until 9. All right. So you have to run it, and you have to have the minimum number of levels. So let's say he plays and he able to reach 20 after 3 levels, and he was able to reach 20 after 4 levels. Who will win? Him. Okay? Who want to start? You want to start? Okay.
All right, roll.
Roll. Okay. 5.
Do I keep going?
Yeah. Roll or hold.
Roll.
Roll. 9.
Roll.
11.
All right, I'll hold.
Hold. You have turn 2 now. Continue.
Okay. Roll.
How much so far you had? 11 plus 4. How much?
Roll.
15.
Wait. So now I have 0?
No, you have what you stopped. I forgot 11, whatever.
11?
Okay.
So, right, roll.
Roll.
Oh, it says I start at 0 now.
Just
Okay,
move
okay,
it.
okay. Roll. 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 Roll.
20.
Okay.
Okay. So how many levels you have? 3 levels.
Okay.
You have 3 levels. You have to go. I have to go hold in here. So you have 3 turns. We call it turns, right?
Gotcha.
3 turns. So let me close this in here, and let me run it for you.
Okay. All right.
So how many? 3 turns.
3 turns.
Okay.
Roll.
Hold.
Yeah.
Hold.
Roll.
Roll. Too early.
Hold on 0.
Roll again. Keep rolling. I hold now. And roll. 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 Roll.
You have to. Oh.
Go to to 0. So
Yeah. Roll. 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 So either it's gonna be a tie or I lose.
okay.
You roll.
Yes, you just have to roll.
Oh god, I'm losing.
You already lost, right?
Yeah, I know.
Continue. Just let's.
Yeah, roll. 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 And then roll. 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 Roll.
Good.
Okay.
So it took you 5 turns, 3 turns. So next time we'll celebrate. We'll give you the $5. Okay. All right. All right. So let's have. What time is it?
2:30 to 4:40.
2:30. Let's have a break for 5 minutes and we'll come back. All right. Yeah, of course. Right. Okay. So we'll continue here. You remember from your other object-oriented programming courses that you learned about like public? So far we're learning about public attribute, right? For the class member. In C, for example, or C++, what you have?
Private, public.
You have a private and
Protected.
protected, right? Or either. All right. So protected or private, right? What's the idea of having protected and private? So you did, all of you did object-oriented programming. Who did not? Who did not? You did not do object-oriented programming. Why? What's your major? Computer engineering. You did not take any course with object-oriented programming. Okay, that's interesting. How about you? Okay, what's your major? Electrical. Okay. How about you? You decided to do object-oriented programming. Okay, all right. So same thing, same idea, same idea. So let me ask you, you're an expert, right? You did it in Java. Can you tell me what does new private do when you make an attribute private? What does it do?
So public is access to everyone. Private is only access to a certain user.
Certain user. Sure.
Private you only can access inside the class. And public you can access.
Okay, that's a much better answer. But private, when you make that private, how do you access?
You got it?
How do you access the
Before I couldn't get-
attributes?
I didn't work
Read them
out that
and
well.
good, write to them, right?
3 and 4.
I'm focusing on the people in the back, I'm not sure where they are in the back. Okay, so you're right, right? So when it's public,
Oh, yeah.
any function can read or update the value. But when you make it a private, only methods belong to the class can deal with. So it has nothing to do with users. It has to do with you as a programmer. You don't forget and you try to access a private value from outside that class, right? So that's what is a protected. There's a protected kind of between private and public. But in here we have a private. So when we make a variable, when we make attribute as a private or public, Is it really protecting? Is it really protecting? Really protecting?
No.
Okay. Who think it's not really protecting? It's somehow protecting. It's somehow protecting.
It's not protecting, it's just hiding data.
Huh?
It's hiding data.
Hiding data. It's hiding the data. It's hiding the data. So the idea in here to have a private is to try to protect the data from you as a programmer to use it in the wrong way. Or you program and try to modify it in a wrong way. Alright? So that's what it is. That's what it is. It's just to have like a solid program that you write. Okay? Unfortunately in Python even you could have a private, there's nothing to protect it, you have a private, okay? But it's also you could turn around it. That means you could have an attribute as a private, but still you can access it from outside the class. Certain ways. We don't have to talk about it, but there's, okay. So, anyways, so at least you know, so how you make any variable or attribute a private? Double underscore. So if you start with 2 underscore, so in here the value, before it was a public. It was a public. In here, it's a private. When I proceeded with 2 underscore, it will become a private attribute. Get value, okay. So when I make an attribute a private, the only way I can access it through, talk to me, through methods belong to the same class. So in here, what did I have to do? Add now. I have to add get value and set value. Roll from before. So before I did not have this, I did not have that. I have like attribute and I have one method. Now I made this method what? Private. Because I made it private, the only way I can access it, what does it mean access? Read and write. Read and change the value through methods in the class. So I have to add 2 methods. The first one, get value, and the other one, set value. Clear? That's what it is. Nothing else. Just we need to know how to do it now. That's what is private. We need to know how to do it. So this is a public methods for getting and setting attributes. How many attributes we have? 1. What is it? Value. So these are to set and to get. And another public method which we had it from before. Clear? So in here we go back to our die. So now we made it like private. And okay, in here a different way is using something called property. Property. So focus on this. When you make an attribute a private, you have to find a way to access it. Access means read and write. Read and write to it, right? There's 2 ways in Python. The first one is by creating 2 functions, one to set and one to get. That's one way. That's an old fashioned, which is used in Java, in C++. The other way is to use something called property. 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 All right? Most of us, because we come from Java and C++, we still use the old fashioned where we use setter and getter. But in Python it's much more easier. We could use something called a property. I'll show you how. Clear so far? Anybody's confused? Please, when you have a questions or you're confused, stop me. That's your right to stop me. You know my rule about the questions. There is no silly question. There is no wrong question. Every question is valid. Every question is important. Stop me before we continue that you can understand. So for example, in here, the die class with a public attribute named value. So, value in here, is it a public or private? Public. Why? Because it does not have underscore before, 2 underscores. Okay, so it's a value and row. That's we have learned from before. In here, to access it, look in here, die. I create an object of die. die that value equals 10. Can you have a die with 10?
Yeah.
Yes.
Well, yeah.
No.
No.
In real life, no. Okay, 1 to 6. But in here, did it work? Did it work? Yes. Why? Because my attribute is not protected, it's not private. Okay? That's what meant. It has nothing to do with users, my friend there. Are you with me? Okay, it has nothing to do with users. It's how to be protected, right? So print die and then die. So in here, what I'm doing in here, what does this sentence do? Getter, I'm getting it. In here, what I'm doing? Setter, I'm setting it to 10. Setter and getter, that's what we do with the values. Read and write, right? So die equals 10. Oops. So in my program, I was able to do that. I was able to do that. That's not the way how we write protected programming language. Okay? Not okay. All right. So the die class with a private attribute named value. Now, I made it what? Private. It's a private. How I made it private? To underscore, right? And the initial value is 1. All right. And in here, because I made it a private, I have to add 2 functions, setter and getter. So for getter, okay, get value self. So just I'm returning the value. I'm returning it. Just reading it. Okay. To set it, okay, random range from 1. So it will give it a value from 1 to 6 only. So that's the only way I can set it. If I go in here and I say die underscore value equals 10, what will give me?
Arrow.
Tell me go to your mom. It's not going to run. Okay? Why? Because I'm not allowed anymore to use this sentence. The only way I can set this value through a setter. Okay? So in here, so it gave you a mistake. So in here, for example, I'm creating an object. I'm rolling. Print die, it will give you the value. All right? So that's what is a private. To make an attribute a private, I'm preventing assignment and reading directly. I have to have something in between, which is methods. These methods, when I write them, I have to make sure I write them very well. That I read the correct data in the right format. And when I write to the attribute or change the attribute, it has to be the good values, the valid values. Okay? All right. Maybe I use this like this, but okay. All right. All right. So in here, the die class with methods that access a private value in here. So what's the value in here? Private, white underscore. What is the default value? 1. So this is get value. What is this? Getter. And then here, what is this? Setter. In the setter, what I have to make sure in the setter? That when I set a value for a die, it has to be a valid one. What is the valid values? 1 to 6 only, right? You agree? So in here, set value, I'm passing the value. Now I need to check this value I'm passing. So if the value is less than 1 or greater than 6, I raise a value error. Die value must be from 1 to 6. Otherwise, I assign a value. So I cannot anymore assign it with assign. I have to call this function. Yes, sir.
Can you also do try in Excel?
You could. You could, right? But that's simpler. You raised. That's an exception. Okay? Yes. Okay? So you raised your own, remember you could raise, you raised your own error. Okay? You could say try and then raise one of the standard errors, there's no problem. But in here you raise your own error. Okay? Same thing, right? Clear so far? Okay. So this is the old fashioned. This is the old fashioned. We use 2 methods, getter and setter. All right? Okay. So code that uses the getter and the setter. So die, I'm creating a die. Okay. Die set value 6. Can I say, for example, die dot value equals 6, like this, I can't anymore. I can't use the assignment. I have to go call the setter to do that. If I do set value 10, I put 10 in here, what I will get? Error. What the error says? Go to your mom, right? It will say what you have raised in here. It will tell you die value must be from 1 to 6. Right? All right. All right. So that's the way. So if I say set value -1 will give me, it will raise this error that I have created. Right? All right. So that's what I need you to use. Learn this using a property. So there's something called properties, functional properties in Python. We'll talk about it next class. But for now, if you say at a property, that means what? Getter. At a property name, setter. So this is setter, this is getter. Okay. So for example, in here, so the value, is it private or public? Private. Why? Because 2 underscores. What is the default value? Is 1. Then, now the funny thing, the nice thing, I could use the same name. So what's the name in here? Value. 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 Okay? So forget about this. So the function, I name it same name as the attribute. Passing nothing. Return self underscore value. What is this? Getter. Just to let the compiler know it's a getter, I have to add this on top of it. Add property. That's it. Okay? So you see value. So the value, the attribute became also kind of a function name now. A method name. Alright? All I have to add property. This is what? Getter. If I add value.setter, what is this? Setter. And notice in here, what's the name of the method? Value. What's the name of the method in here? Value. What's the name of the attribute? Value. Let's go few steps back. In here. All right. What's the name of the attribute? What's the name of the getter? Different name. Get value. What's the name of the value in here? Different value. Different name. All right. So in the yes.
So what is the advantage of having same name of value?
You know in a second. Just watch. All right. So that's what the value, right? So let's say, let's take a look how now we use it. Okay, die. I'm creating an object. Then die dot value equals 6. That's the advantage. Now you go to the old form, but it's protected. So when you say die dot value, what will go call this now? It will call this. Function, how you can do it? You have to call the function like that. Okay? So that's the main advantage. You see, die value. But remember, there is a property. That means it will be protected. It will run the function. And look in here, print die equals die.value. In here, what is it in here? Getter. In here, setter. Okay? Without needing to have a complex code calling functions and all of that. All right? You are free to use the setter and getter methods or use the properties. Okay? Okay? It's much more nicer. So in here, for example, look in here. You asked me, look in here. So if I didn't set the property, if I said die.value equals -1, what will give me? If I did not set up the properties. It will accept it. It will accept it. Now, because I made it a private and set the property, will it accept it? It will raise the error. It will raise the error. Okay? It's a very nice, actually. That's how we should use it. Okay? So in here you have a list. The list which is a private, and the value is a private. So because okay, it's a private, I have to use two functions, setter and getter, or I could use the property. Same thing in here. The list, because it's a private, I have to use two functions, or I could use the property. Okay, so it makes sense. Remember that when you write a complex code, that you're gonna write thousands of lines. So if you have a way that to reduce the number of lines you're gonna write every time, that will be a good thing. That will be a good thing. All right. Okay. So this is the same program, the DICE program that we have created, but we have changed the attributes to private, and we have created the functions. We created so here, for example, properties. I'm sorry, properties, and so take a look at it. Okay, it's the same. Okay, but we are not using properties. This program. Anybody remember this game? Who's the winner? Okay, we have a winner, right? Okay, thank you for your guts. So for accepting to play, right? This is I'll keep for you to understand the game, right? The game is written, and that's the idea. There is two classes. The first class is die. The second class is dice, which is a collection of die, right? And we wrote the game. Okay. So I'll keep it for you to take a look at the look at. Okay. Now there is important thing: inheritance. Did we talk about inheritance today?
Yes.
Yes. Okay. Anybody reminds me about inheritance? What did we say? I'm focusing on the people in the back because I think they need my attention. Okay? So, what is inheritance? Can you tell me what's inheritance? Speak up. Okay, so the child class inherits a parent class. What does the child class inherit from the parent class? And attributes. So you inherit. Do you agree with this? Do you agree that the child inherits methods and attributes? Do you agree? You agree? You agree?
I don't know.
I agree. Do you agree? You agree? No, they are all telling you the truth. You are getting a bit corner. Telling the truth. So when you have a parent and you have a child, the child will inherit from the parent all the attributes and all the benefits. Okay, we'll draw it in we'll see it. Okay, does the child class inherit money from the parent attribute from the parent class? Money. Yes or no? Courageous, be energetic.
No.
No?
No. Yes.
Yes. Okay. Yes. No. Yes. If the parent has an attribute called money, it will inherit. What's wrong with you? Sleepy? All right. Okay, next time, guys, I need you to compete in the first row there. Okay. If possible. I'm not forcing you. Okay, otherwise, all my lecture will be from here. Okay, so you get a feedback. Okay. My job is to help you to be in a track, that's all. Okay, otherwise, it does not bother me at all. Okay. All right, so you understand the whole discussion in the back there, even in front, right? Okay, so does child class inherit money from the parent? Class? Yes, if I have an attribute or a method in the parent called money, right? All right, so let's be serious a little bit. All right. All right, so in here, for example, product. Okay, what's a product? Class. Guys, I need you to talk to me. So yes, it gets on my nerves when I talk to myself. If you are not ready to talk to me, just watch the video at all. Okay, or don't watch it at all. That's okay. All right? Okay, talk to me. So what's a product? It's a class. Okay? And name, price, discount percent. What is that? Attributes. And these, what are these? Methods. So we have a class which has 3 attributes and 3 methods. What's a book? A class, a child class from the product. All right. How many attributes it has, the book? 4. Who said 4? Excellent, because it inherited the 3 plus the author, right? And how many methods it has?
4. 3.
3. It has 3, guys. And then wake up. Why it has a 3?
One's overridden.
Because the last one in here, get description is in here, so we are only overriding it. So how many it has? 3. How about this idiot in here, the movie? How many attributes? 4. How many methods? 3. All right. So that's the inheritance. The inheritance. So these are overridden. Okay. So this is a very nice structure, right? So we have a product. You know, if for example, if I go in here and add author and add year in here, will it work? It will work, right? So if I have like a table, year it will be null value because it's not a movie, right? If I have a table in here, the book, the author will be what? Null value because a table does not have an author. But you see how much waste? Because I will have so many products don't have authors, and so many products don't have year, right? But this will be a nice way. I create like subchild, a subclass or child of the parent that has the extra attributes and the extra methods I need to use. Very nice, right? That's object-oriented programming, right? Okay, so it's a very simple. How can I do it? Okay, very simple. So for example, in here, you have a class called product. Class called product. Where is the product? Here. Okay? So the first function, the first method I always define in any class is what? Constructor. Do I have to?
No.
No. Why? Because if I don't put it, it will be inherited from where? From the parent class, which is object. Is it good to have it?
Yes.
It's always good to have it if you can use it, if you need to use it. So it's underscore init underscore. What is the first argument we pass? Self. Then we have the 3 what? Attributes. It's a good habit always to initialize it. You have like initial value. It's a very good habit if you can. Then we finish that, the constructor. Then how many methods I have? 3. I write the 3 methods in here. I write the 3 methods. So what is this? A class. Which class? For a product. All right. Now I'm creating another class called book, inherited from product. So what I have to do? I have to create the constructor. All right. I have to create the constructor. Okay. But how many in the book? How many attributes I have? Only one, which is the author. But the rest of the 3 are coming from where? So I have first, what should I do? Product, or I could write super. Product or super. The parent, super, product or super, whatever you like. I prefer super myself. Okay. I'm calling what in here? The constructor of the parent class. Self, name, price, discount. So now I'm calling it from the parent. Which one is missing? The author. Very self.author equals author. So I initialize the first 3 from where? The extra one, the new one, I got it from where? Here. I did it here. Okay. Now, how many methods the book class has? 1. Which is overriding which one? From here. This one, get description. Get description. It's overridden. So I write the way I want. I don't care about the details. So override the get description method. Okay? If I don't write this at all, is there a problem? Not really, because it's gonna call from the parents, right? It will not be as good. Why? Because in the parent, okay, product dot get description self plus by, I could add the author. So it's like it's a specialized description for the book. All right? Okay, so product, book, movie. Movie, the same thing. So now, for example, the book subject class, this is a book subject class. So look in here. This is get description from the product, get description from the book, get description from the movie. They are three written in a different way. If I'm calling this function to the movie, it will do it this way. If I'm calling it for the book, it will print it this way. If I'm calling it for any other, it will print it this way. So that's what you call it, overriding. Overriding server class. Okay? Take a look at the program in here. This is the main engine. From objects, import three classes: product, book, and movie. I could put it in a separate file, right? Then I have defined the file to show the products, and then the main. What does the main do? Okay, it will initialize the products, and you can do whatever you want with it. Okay. There is a function for you now in this program. How many classes you have? 3. If you would like to know this object belongs to which class, can you do that? Yes. There is instance. So is this object instance of this class? Is instance of a book class, or product class, or a movie class, or what class? So sometimes inside the program, always you have to know that. Okay? Function will tell you. So what will be the output for this? What is the output for this?
Class.
What's the return value?
Boolean, class name.
Boolean. Boolean, no, I think it's Boolean, true or false. Because you're asking, is this object part of the book class, true or false? It's a Boolean, as far as I know, right? It's a Boolean, right? Yes?
Can we use function type?
No, type will tell you it's a class. That's what it'll tell you.
Yeah, it's gonna return class.
It's return a class, yeah. What are you going to benefit from this?
You know which class we are.
All you need to know, true or false, right? To take a decision. If you're going to return a class, then you have to parse what is the data and then determine which class. This is easier for you, right? Right? So like in here, for example, example in here. Okay, so show product. So print product data, print name, that's the product name. If is instance of a product, if the product is part of book, okay, then which one I have to call? Which function I have to call? Product author. That's why I need to know, is it part of book class? Then I could add also what? The author. Is it part of the movie? Then what I have to add? The year. If it's not from the book and from the movie, I don't have to add anything. It will be normal. Printed without the author or the year. Okay, it's just for your logic. Your way, type. Okay, type. Type will tell you long line that tell you this is a class, the name of the class. Okay, right? So you're gonna go for this class and look for what? Much more easier.
Only the type class.
Sure.
It's a line.
In line, yeah, of course. It does not tell you. This will tell you what? True, true or false. Right? And so on and so forth. All right. So this is the same program you could take a look at. All right. So there is something called overriding, overloading, right? Overloading, overriding, right? So there is a lot of functions. So there is a lot of functions. For example, a string in here, right? What's a string in here? There's a function, right? Inherited from where? From where? From the object. So for example, when I say, for example, y equals hello. All right? When I say print y, what does print do?
Hello.
It will call this inherited function in here. Okay, so basically this will be converted to this one. All right? Okay, so you could override it. What does it mean override it? When you type print, it will write it in a different way. So look in here, for example. So for example, str self return a string from object. For example, look in here. Okay. So you define, you overriding the string self, return self name, then you're adding what? Bar, string, price, bar, and the discount rate. Okay? Let's say that you're creating a product, which is in here, it's a hammer. And when you say print product, okay, the print will call now the overloaded function. So it will print it for you like what? Like this. If you did not do this in here, okay, it will print what? Nothing. Until it's a clause, that's it. Yes.
Is the capital S a typo?
Is what where?
Capital S in the middle STR?
Yeah, of course.
Okay, okay.
Thank you.
Yeah.
Okay. So the console, if this is not this, it will tell you this. It's an objects, products, object add, and the address in the memory. Right? So there is overriding is a very important thing as you could do. Okay. So for example, another example for overriding, for example, you should learn it, and I think you'll have it in the assignment also. So for example, if I have 3 plus 5, what does it give you? 8, right? 8, right? Okay. If I have, for example, an object, for example, I have a class, for example, square. It's called square. Okay? All right? And, you know, and if I say this is a class, okay? So let's say square 1 equals 8. Square 2 equals 20. This is the area. If I say square 1 plus square 2, what does it give me? Error. It give me error. I cannot add boxes. I cannot add squares. Can I add squares? I cannot. But you know, you have to know that this one, it's a function. It's a function, okay? What is this function? It's a method. What is a method? Underscore add. So I could override this function. When I do square 1 plus square 2, it give me 28. Yes?
Why they have 2 underscores?
Huh?
Why they have just choice?
The guy who designed Python, you know, like to do it this way.
There's no specific reason.
There is no specific reason. And as far as I know, even if you make it 1 underscore, it will work. Okay, but that's how it's designed. Okay. Clear? There is the other thing is something called iterators. We're going to talk about iterators right more. What is iterators, for example? When I say, for example, for I in a list, for example. So why I'm able to do that? Because I have an iterator. What is the iterator? You could iterate them, all right? So every time you loop, it will run next, like a pointer. So if I have a list, for example, like this, okay, 1, 2, 3, 4. So at the beginning, there's a pointer. Points to where? To -1. Okay, then I iterate. It will point to where? To 0. The pointer points to 0. Then points to the 1, the index 2, index 3, right? Okay, so I could also create iterators. I could create iterators for what? For the objects. So for example, in here, okay, remember this problem, right? This is init. What is init? Constructor for the dice. How many attributes I have in the dice? 1. What was it? A list. List of what? Of die. Remember? List of die, right? Now, if I need to iterate, to be able to iterate through it, so what I have to do, I have to create 2 methods. I have to override 2 methods. The first one is the iter, for iterator, and the next one is the next. So for the iter, very simple. Self underscore index minus 1. So what I'm doing, I'm making the pointer at the very beginning, before the first, okay? When we hit next, it's gonna go to the first one. Then the second loop will go to the next item, third item. And then I have to write the next, okay, next self. So if self index less than the length minus 1, greater than the length. When it's greater than the length, when it goes above the boundaries in here, you're gonna raise a stop iteration because you are outside of the range. All right. If the index is, otherwise you're gonna add, for next you're gonna advance the pointer and you're gonna get the next value, okay? Anyways, what time is it? Yes.
Do we have the notion of private for methods?
What?
The notion of private.
Private what?
Like we said, for attributes we have private or public. For methods, we can do private methods?
No.
We can,
All right. His question was, like in Java, for example, also you could have public, protected, and private methods. Do we have that in Python? The answer is not I know of. Okay. All right. What time is it?
3:28.
Okay, still have a lot of time. All right. All right. Okay. This example for that, I leave it for you. I leave it. Okay, exception. How to create exception? I leave it for you to take a look at it. So in here, I added many slides for you. What does it talk about? Yeah, this for raising an error. You take a look at that. All right. Okay. In here, for example, there is underscore doc. There is many of these that you could override. Okay, override. So what does it underscore doc? Okay, so for example, always after the class, when you define the class, you put explanation doc string for the class. So if you say, for example, print my class underscore doc, whatever you give explanation here, it will be printed for you. All right? So again, the first, if you need to explain the class, and that's what I need you to do for all the classes you create. You follow the name of the class with explanation. This is my second class, for example. Whatever the class. Yeah, it's like a comment, right? So always for help in the future, you need to read about the class. You could print my class underscore doc underscore, and we'll print it for you. Okay? All right. So there is also, this is what we do in here. There is many of these, okay, that you always can write. Okay, yeah, that you always can write. I gave you a link in here. Take a look at them. Okay. Also in here, we have learned multiple inheritance. So far what we have, for example, you have base 1. This is a class. Base 2. You could have a class that is inheriting from both. So inherits from base 1 and from base 2. And that's what we did. So multi-derived, so base 1 and base 2. Just you make a comma between them. So what are the attributes of this? It will be all the attributes. So it will be features of base 1, base 2, and plus multi-derived. Plus what we add there. Okay? What is the sequence? The sequence left to right. Left to right. All right. Also in here, what you have in here? Multi-level. So inheritance is multi-level. So derive 2 is inherited from derive 1. And derive 1 from the base. So basically the features of the derived to coming from where? From here and here. And here. Okay, it could have multiple derived. So in here, okay. So search order is, so the question is, all right, let's say that we have a method in here. A method here, I'm sorry. And you override it in here and override it in here. When you execute it in here, which one is going to execute? Here. Okay? If it's not in here, it's going to take it from here. If not here, it's going to take it from here, right? So search order is to start with the multi-derived, then the base one, then the base two, then the object. This order is also called linearization of multi-derived class, and the set of rules used for that, MRO. Anyways, this is not in your textbook, I add them for you. So for example, look at this. If we have, you have to understand, if you have like object, you have class X, Y, Z. So M is inheriting from A and B and Z. A is inheriting from where? X and Y. B inheriting from these two. What is the order? What's the order? If I need to know what's the order. Okay, so for example, class X, class Y, class Z. Then A inherits from X and Y. B inherits from Y and Z. M from B, A, and Z. So if I type, for example, M, which is in here, dot MRO, it will tell me the order of the inheritance. So M, the first thing is, okay, after, where is it? In here, I think. After the class, okay, A, then B, then, I'm sorry, M, B, then A, X, and so on, so on. I mean, you could follow that, okay? Just an example, okay?
First.
Yes?
If M inherits A,
Yes.
would it also inherit X and Y?
Sure, all the way up,
M inherits everything.
all the way to the object. The question, what order? Okay, that's the question. What? Let's say that you have, for example, a function called, let's call it, what's your name?
My name? Mateus.
Matthews, right? Let's say that we have a function called Matthews in here and Matthews in here. A inherits X and Y. Which Matthews can I use, this or this?
Nice.
Huh?
From the
Maybe X. Okay? That's why it's a very important, the order of inheritance. Maybe Y, depends on how the sequence, how you write. So what I'm trying to say, okay, A, for example, where's A? A inheriting from X and Y, right? All right? So it will use the Matthews of X. If it's not there, it's going to use the Matthews of Y. If I flip them, if I put Y before X, which one first going to inherit? The Y. That's what I'm trying to say. It's a very important to see the order. Right? And forget about the small assignments that you are doing in here, a few methods and all of that. When you start working a project, massive product, that will have many classes. Each classes have many methods, and each class inherits from multiple classes, and there is multiple methods. So you have to know which one, right? So that's a problem. So that's very important for you to understand the sequence of the inheritance. A simple way to do it is just to execute this command, like a print m.mro. So you know the sequence that you expect. Yes.
What happens when there's the same method names for, like, let's say an X and B, and you use M?
For x and?
So B and X have the same method.
Okay, and where are
And
you?
then in M, you call that method.
Okay,
It'll just,
that's again the sequence.
it'll go from B.
B.
Okay.
Okay, you have to look at this.
Yeah.
That's why you click here, the sequence.
Okay.
That's your map.
And that'll tell you what.
That's your map, exactly. So here's a question. If I have a method in here, I'm calling it from here. Is it going to execute this first or this first? Depends on how you write your code, how you derive the classes. So to be sure, always run this to know the map. This before That's a good question. Thank you. All right. What is the operator overloading? I just explained, spoke about this, okay? So for example, let's say, in here I'm defining the point. The point has what? X and Y, right? So, X is 0, Y is 0. X and X. So if I say point 1, which is 2 and a 3, point 2 is minus 1 and 2. If I type point 1 plus point 2, what will give me? Go to your mom. There is nothing. How can I add this, right? All right? So now I need to override it. So I have to override it. So look how it's very easy how to override it. So how you override it? Okay, very simple. Okay, where is it? Did I override it somewhere?
STR.
This is str, the string. Okay, the type. So how to type it? So maybe in the next slide, I think I did. Yes, in here. So this is the point, the same thing, right? Here overriding the str, right? In here I'm overriding which one? The add. So add self and another. So what I did, x self dot x plus other dot x self dot y, the y self dot y plus other dot y, and return a point. So after I override it, what I will do, p1 equals 0.2 and 3, p2 equals point minus 1 and 2. When I type in here 0.1 plus 0.2, 2 plus minus 1, 1, 3 plus 2, give me 5. So basically, any operator, what are operators in Python? Add, subtract, multiply, divide, greater, less, greater than, less than, greater equal, less than equal. All the operators, what they are functions. Derived from where? From where? From the object class, which you could do what? Override it to your purpose. So if you have a class of boxes, you could override the plus sign to add the volume of the boxes. Right? Yeah. All right? So that would be part of one assignment. You could do all of that writing, right? Okay. You see in here, these, okay, for example, add, sub, multiplication, mul, power, floor or whatever, mod, left shift, right shift, and all of these you could override them according to your logic. Okay? Very simple. Overloading comparison operator in Python. So this is also what I'm doing in here. Overriding what? Less than. Take a look. Less than, okay? Property, I just explained the property very well. I think I don't want to go through it. Okay, add a few more examples for you. So, you know, for example, here you have class person. And here, what you do in here? Add property, what you do? What is this? Getter. And here? It's a getter only I have in here. It's a getter. Okay, in here. I have in here. What is this? Getter. In here? Setter. In here? Deleter. Okay, deleter. Take a look at the examples. I wrote some code for you. Okay, and when you go to the notes, you'll find the full code. Okay, try to, okay. Same thing, object, properties, whatever. So in here, all of these, in it, you could override it. String, class, equal, add, iter, len, many. These are just examples of things you could override. It's so cool language. I mean, seriously, after you program for a while in Python, okay, the problem if you love it too much, because you'll enjoy it more than you focus more into the logic, what you want to achieve, than than the complex language you have in Java and C++ and C# and all that. Okay, because so many things in Java or C++, you need like many lines to do. You could do it in one line in Python. Okay, especially when it comes to data science and it comes to machine learning and deep learning. So the next section I leave it for you. It's a very simple thing: how to design object-oriented programming. That's an easy thing to do. So first of all, you have to think about what are the real-world system. Then you have to divide it into classes and how you create them. create the objects. This depends on the problem. So identify the data attributes, subdivide each attribute into its smallest useful component. Identify the classes, you have to create your classes. Then identify the methods. Each class has attributes. You have many attributes. You could put all of them in one class, or you could them in few classes and inherit them from each other, or they could be parallel. You could have parent, child, subchild. That depends on what? In the application and in your design. So if I give the same problem to this person, the winner today, okay, and I just want to say the loser because he's not loser. This person in here, okay, he will design. They might have different design. It's just a matter of design and how you need to do it. Okay. So I mean, if you look at any web page, I mean, look in here. For example, in here, in here. So you need to look at, for example, what are the attributes. Then after that, you remove some of them which are not important, right? Then you create your classes. You do the design, how you're gonna do the design, all of that. So there is example in here, but this is, you should know it from before. So that's basically, and by the way, what I want, before I leave, okay, I would like you, if you notice in the PowerPoint that I add some references at the end, a very good reference is this one. So this is a very nice online textbook. So especially in the classes, okay. There, I mean, just go through it. I mean, of course, the class and object. There's a lot of things that we cannot cover in the class. Okay. So this is a very good reference. It will help you a lot to understand a lot of things. All right. Again, I mean, like if you need to be a programmer, good programmer in any language, you have to know what this programming language gives you. Okay, what offers you? What does it offer you? Right? So it offers you a lot of tools, a lot of classes, a lot of methods, a lot of things, how to deal. So the more you read, the more you know, the more you become familiar with it. So this is one of the references I recommend you go. Any questions? Thank you so much.